thank you on behalf of SWAN and the SWAN Americas Alliance for joining. We're here on the webinar on funding smart water, expert insights from source to tap. We have a really exciting lineup today for you all, including LADWP, Olea Edge Analytics, featuring a great case study from the city of Atlanta, Aqua Mentor from Ohio with Fontus Blue, Aquatic Informatics featuring city of Marlborough, Massachusetts. So a lot to cover here. For those asking, this webinar is recorded and will be made available for SWAN members on the SWAN website. So we encourage you to just listen in. Don't worry about taking notes. Everything will be provided for you afterwards. Quick, very brief intro. I'm Shirley. I lead innovation and strategy for the SWAN Forum globally. We are a global organization leveraging the smart water sector around the world, founded in 2010. We bring together thought leaders around the world across drinking water, wastewater, and stormwater, from utilities to solution providers to consultants in the entire ecosystem. And our work is amplified by regional alliances, work groups, and affiliates. You're more invited to learn more on our website, swanforum.com. A few quick plugs in terms of events coming up. Next month in Spanish, we will be exploring digital water trends in Latin America. That will happen March 23rd. It's completely free and will happen at 10 a.m. Looking at really Latin American utilities and thought leaders on different trends shaping the region. I will soon put some links here for you all to join and register. So do consider joining. And I think many of you are already familiar, but our flagship event, the SWAN Annual Conference, is coming back strong in DC towards the end of the month, focused on the theme, Connecting Innovation to Impact. We have a lot of great agenda planned for you that will be released shortly with speakers, again, from all over the world. So do plan on joining us. And again, I will share some links to these events coming up. But without further ado, you're here for this specific reason, focusing on 14th webinar. This event specifically is being hosted by our SWAN Americas Alliance, one of our oldest alliance to help spearhead smart water across the region. This specific event is hosted by the events subgroup, which is co-led by Alexander Biddlelow of LADWP and Brent Thompson from Badger Meter. And with that, today's moderator is one of our co-hosts, Alexander Biddlelow from LADWP. Alex has been with the organization for over 4 years and has been instrumental to our growth in the region. With that, Alex, I'm going to go ahead and hand things over to you.
Awesome. Thanks, Shirley. I will just request control real quick. And thank all of you for coming. Good morning or good afternoon, depending on where you're tuning in from. So my name is Alex Biddlelow. I work at LADWP as a mechanical engineer. And my day job is working on designing and constructing new water system facilities. And about 3 years ago, I joined our smart water group, helping to just accelerate pilot projects and new smart water technology at LADWP in the Water Information Network. And after getting involved there, I was really just excited about this side of the water system and the industry in general. And that's how I learned about SWAN. And about a year ago, I ended up getting involved in the event subgroup. So here we go. So like Shirley said, I'm a co-lead for the event subgroup with Brent Thompson. And we are a part of the Americas Alliance, which is our largest and most active subgroup. We launched about 6 years ago. And the goal is to really just help accelerate the adoption of smart water technology in the water system and in the North and South American region through the SWAN community. So our subgroup is really focused on trying to create physical and virtual events to just foster knowledge transfer and collaboration within the industry. And there are 3 other subgroups: the outreach, research, and partnership. And if you're interested in the smart water space, or you're just interested in what's going on, we'd really encourage you to get involved. Not everybody is going to be involved in like a leadership level, but even if you just log on to a call or jump on our webinars, we'd really love to collaborate with you and work together to help achieve the goal of accelerating smart water. So just a little thank you to our Utility Review Committee. This webinar series, we're doing 3 for this year, so we already had one. This is the second one, and keep your eyes out. We've got another one coming down the pipeline. But this whole webinar series would not be possible without our Utility Review Committee. So Elkin, Amanda, Chad, thank you, thank you, thank you. We got a ton of submissions when we requested folks to be presenters, and these 3 folks did the hard and grueling work of doing a blind review process of all those submissions, and they helped us find the panelists on this call and on the other webinars that we're hosting. And so today we're going to be talking about smart water funding specifically. We are going to be recording the session, so if you have to answer an email or something, you will be able to come back and revisit this in the slides later. We are going to do the 3 presenters and just run through those for a good flow. But you'll notice in the bottom of your screen, there is a little question and answer section. So feel free, if a question comes up to your mind, just type it in there and we will address that at the end. So our presenters today are Quinn from Olea Edge Analytics, who's going to be presenting a use case with the city of Atlanta. Next, it'll be Dave from Aquatic Informatics, presenting alongside Matt and John from the city of Marlborough, and Bill from Aqua, Ohio, and Ashley from Fontus Blue. So without further ado, I will turn it over to Quinn. So Quinn, take it away.
Thank you, Alex. So today we're going to talk about finding funding and operations. And can we advance the slide deck, please? Thank you. So we know that utilities have multiple different opportunities for funding, from bonds to loans, grants, and even the IIJA. And so we wanted to talk about today how we can leverage that funding by finding more revenue in operations and creating even more of a benefit. So right now, there are a couple of options available when you have funding. A lot of times the funds are used for very cost-intensive capital projects. And there's another option out there that involves technology projects that have a positive return on investment that can actually help extend funding in dollars. So, and you can see in option B, by investing those funds in a tech project, you can generate more return on your investment and therefore invest in more technology, capital projects, or utilize that funds for other initiatives of the utility. So let's talk about a real world example with the City of Atlanta, the Department of Watershed Management, and how they utilize the option B approach to investing in technology and how it has benefited them. So Atlanta invested in technology that was focused on an asset class that they knew they needed some specific attention on. And so they focused on their large commercial and industrial water meters, because those meters really account for 70% of their annual revenue. They started with a very small pilot of deploying this technology on 19 meters. 10 of those meters were not performing adequately or accurately. And so the city was able to actually identify over $1 million in annual revenue by addressing the issues with those 10 meters. And also those issues with those 10 meters was actually ended up being 33 million gallons in water annually. So they're able to recover revenue and also change some of the dynamics of their operation and have this annual revenue as part of revenue recovery that they're able to use for years to come. So a little bit about how the technology works and how Atlanta's operations utilize the data to make process improvements. So the technology utilizes an edge computing device that analyzes sensor data, and it detects component level failures at the meter. So there are many different failures that can be detected, but Atlanta found that there were 4 issues that they would not have known about if they had not invested in this technology. So that would be issues such as crossover, which I will show a specific example with the data for that, sizing issues, the type of meter at the location for the application of the structure that was there, and also if there are any indications of bypass issues. So an example of what the technology was able to show Atlanta in regards to a crossover failure, which they would not have known about without investing in the technology, and it helped to inform their asset management program, their meter maintenance program, and really how they operationally handled their large meter classifications. So you can see here that with a crossover failure, there's a low flow and a high flow side of the meter. And the high flow side should not have anything going through it until the low flow has reached that crossover range as specified by the meter manufacturer. So when that happens, you know, the throttle valve could be stuck or something could be happening. And so when the flow is going through the high flow side and not the low flow, then the utility is foregoing collecting revenue that should be registered on the low flow side. So the city was able to take this data, go and make the correct repairs. Post-repair analysis showed that they corrected everything with this meter. And this is one of those instances that investing in the technology and having the data available really helped inform their operations what to do. The next example is of a meter sizing on the next slide. So this is a location where they had a single meter, and those single meters are really designed for very high flows. And sometimes things change at the location, the application changes. Maybe it has gone from a huge industrial factory to maybe converted into loss, where now you need to have a way to account for the low flows as well. So our data showed that Atlanta needed to change the single meter out for a compound meter because they were not billing for a large percentage of the low flows that were happening at that location. So the analysis indicated there was a sizing issue. The city did change it out for a compound meter. And so therefore they're able now to start accurately billing for all of the flows that is going through the meter and for the full consumption that's being utilized. So again, by looking at option B and taking this type of approach with investing in technology first, Atlanta was able to have accurate data about their large meters. They were able to have a better operational understanding of what they needed to do for the meter to perform accurately, which then leads to billing accuracy, which also leads to customer confidence and revenue recovery. And so this increase in revenue can help to extend their funding and help them invest in even more technology and infrastructure. So there are some other opportunities to stretch the investment even further. And so let's talk about the next slide, which is sort of a performance-based contracting vehicle, or an ESCO. So an ESCO, actually, they either find cost savings or they find a revenue generator, and they are able to conduct an investment grade audit and guarantee that revenue for the city or the utility for a period of time that allows the utility to have the capacity to do even more projects. So in the case of the example with Atlanta, if we go back to the case, if we remember the case study on those 10 meters, they found over $1 million. So if they had gone maybe sort of an ESCO model, the ESCO would have come in, done an investment grade audit as the revenue generator to guarantee that revenue for the city for 10 years. So they would have been able to actually have $10 million available for them to reprogram into other projects and either more technology or other capital projects related to their infrastructure. So this is one way utilities can actually stretch their initial investment into technology that has a positive ROI. And in summary, funding technology projects can put money back into the utility. We saw that as a successful use case with Atlanta Watershed Management, and it has helped them stretch initial funds. They've invested in even more technology, which is providing them with even more revenue opportunity to utilize for projects, other technology, and perhaps in the future they may further extend these funds by utilizing some sort of performance-based contract or ESCO model. And so thank you for the time today, and I will turn it back over to Alex and Shirley.
Awesome, thanks, Quinn. So next up, we have Dave from Aquatic Informatics, and he'll be presenting alongside Matt and John from the city of Marlborough. So if Dave or Matt or John, I don't know if one of you wants to take over control, great. Take it away.
Thank you, Alex. Hey, everyone, Dave Stadelman. I'm with Aquatic Informatics. I'm the Senior Sales Manager here. It's my genuine pleasure to get to share this really cool customer story with you. With me today are Matt Centella, who's the General Foreman for the City of Marlborough, and John Murphy, who is the Industrial Pretreatment Program and Fats, Oil, and Grease Program Coordinator. Let me jump in to the next slide here, and I want to talk a little bit about the technology that's at the center of today's story. That technology is used to regulate industrial and commercial businesses. Matt and John work to protect the City of Marlborough's wastewater treatment plant and the community from harmful discharged waste into the wastewater stream. And to do that, they operate an industrial pretreatment program and a fog reduction program. Now, operating these programs basically means that they work with the regulated businesses in their service area. Or you might even say they partner with those businesses in order to issue permits, collect wastewater samples, analyze the lab results. They have to enforce violations if and when they occur. And of course, they have to report a whole heck of a lot of information up to the EPA. Now, that's a lot of work, and John and Matt will tell you. So let's actually let Matt and John tell you a little bit more about this, the city and what they're doing over there. So Matt, I'm going to turn it over to you to speak to this slide, if you would. Can you tell us about the size of Marlborough, Massachusetts, and maybe a little bit about the size of your service area, and help us understand a little bit more about what you and John are doing over there?
Yes. So we have 2 water treatment plants. Total, we do a little under 10 million a day. Our westerly treatment plant is the one that all the industrial waste goes to. The easterly has more fog going to it. So 2 separate kind of ideas of what's going to what. We have 14 large industrial significant users, which we consider over 10,000 gallons a day. We have 24 that are under that, but they still have some type of pretreatment system in there. We've lost some fog people over restaurants and stuff over COVID. We're down to 215. When I started it, we had about 300. Restaurants, hotels, office buildings, all that type of stuff, plus 40 dental offices. So we also take the water from Northborough, which is the next town over. So we're technically taking all, they do not have any industrial dischargers, but that they have dental offices, they have fog people too. So we have to kind of work together with them in a lot of capacities to make sure we're getting the right stuff from them. They're not just dumping whatever they need to into their system before it gets to us. And we're an older city. A lot of our infrastructure is from the 1800s, 1890s and stuff, a lot of drainage, sewage pipe. So I&I is a big issue. So we can kind of use a lot of this to find where it's coming from, at least in a general sense, and then it now will come to me, who is now in charge of the water department, to get a little more technical on the I&I aspect of it, how to fix it, where to fix it.
Sure. Wow. I've been lucky enough to work with folks like you, Matt, for the better part of 2 decades here, and 38 permanent industries, and 250 or more commercial businesses. That's after you've lost 75. That's a lot of work. I know. And so let's use that to talk a little bit about more like, what things were like. It wouldn't be much of a story for this audience here today if everything was just peachy keen right out the gate. And so you share with us, if you would, a little bit about some of the challenges that you were facing operating that program, please.
So I took the job about 4 years ago, and we had never had a fog coordinator before. Nobody had ever checked any grease traps in the entire city. We had grease problems, overflows, problems at the plants, all that stuff. So I got thrown 300 industries. The entire IPP program was run by one of our treatment operators, and they were obviously, it was almost an afterthought, I hate to say. So I was basically handed a giant file cabinet of paperwork and said, here you go. We did have they used to be called Linko. So if I say the word Linko, that's who I'm talking about, Aquatic. We had the Linko program, but it was downloaded onto only one computer and hadn't been upgraded in over 7 years. So I had to literally take and basically start from scratch so that I could do the job. Most of the job is you're going into restaurants, you're going into the industries, you're going everywhere. So I needed to get it mobile so that I could go off and do the job on the run. One of my biggest challenges was we were extremely short-handed at the time, so I was also still a water shop foreman. So my first job as the fog coordinator was installing 400 feet of water pipe. So that kind of shows you that I was under a lot of stress to get as much done as I could with what I had. So they were very good. They have a lot of programs that let me do this on the run and let me move around and quickly get information and do the inspections.
Thank you for that, Matt. Those are some significant challenges, to be sure. And when we get toward the end of the presentation, I'm going to ask you to share with the audience how you were able to obtain buy-in and obtain funding for a program like this. But in the meantime, before we do that, I'm going to ask John to share with us a little bit about what the technology that we're talking about here actually does for them. So that's sort of what the state was before you brought in the technology. Let's hear from John a little bit about what the technology is and how it's helping him today, if you would, please, John.
Of course. Hi, my name is John Murphy. Like Matt said before, I do the day-to-day operations of the IPP and fog industry. So I'm doing all the inspections, all the paperwork, everything of that nature. I use the Linko system every day, whether it's checking in on industries or physically going and taking samples and doing inspections. I actually completed a IPP inspection this morning. I was able to basically have the entire report generated like you would on a Word document, fill in everything, ask the questions, click yes, no, have the company sign it, and then once everything is signed, it's permanently saved. No corrections can be made to the document, and then I can email them a copy, and then I have an online copy for our records when we submit them to the EPA. For the fats, oils, and grease, it's more or less the same. I can input the state of the restaurant, how clean it is, what the levels are. I can take pictures, and it's also programmed so that if the holding capacity of a grease trap is 95%, it'll take in the readings I get and tell me automatically if that grease trap is in violation for being over capacity. And with that, it'll notify me, and I can then tell the business right there that it's over the capacity, and I don't have to do any of the math, because sometimes it's adding inches and feet, and trying to do all that on the fly can be a little tough.
I have a hard enough time when I'm behind my computer with a calculator, so I can relate, John. Well, right on. Well, thank you for that. It really sounds like that technology has made a meaningful impact to the workflow and your time. And back to Matt's point earlier about really freeing you up to do all the other things that you guys have to do above and beyond, operating these programs here. And so here on the screen, we see some of the results. I'm not going to read them to you, but I think what's really relevant to this audience is Matt, I'd like to return to what I prepped earlier and ask about, how are you able to get this done? I mean, all this, back to the title of the organization, big city technology and automation clearly returned good outcomes for you folks. And that's why people value technology and automation. But in that spirit of funding, technology costs money. How are you able to, work with your procurement? How are you able to obtain support from your city? What was that procurement process like? How are you able to justify bringing in tools like this? I mean, small town, small budget, right?
So I was very lucky with the assistant commissioner that I reported to, was very good. And she was where we had started the FOG program basically from scratch. I kind of had a little more leeway than if it had been around for a while. It was kind of, you need the money. All right, we got to do it. She found the money for me to be able to do what I have done. And she realized that we were shorthanded at the time, and we're probably going to be shorthanded for a while. So she realized that there was a lot you're saving in the long run. If we're not having backups, if we're not having industrial accidents, if we're not having any of that stuff, that's expensive. That's notice with EPA, notice with the Department of DEP, all that other stuff. You have to, put it in the paper. I don't really want to see myself on Channel 5 anytime. So spend the money now, and it takes away a lot of that. So I was very lucky that my commissioner has done that, and I've gone along and been a great promoter for John of if he needs anything, let me know. I now do a lot of the procurement stuff. So he needs something from you guys, run it by me. We'll talk about it. Anything that can make his job easier, because it's a very time-consuming job. You're driving constantly, back and forth, back and forth, back and forth. So when you have to sit down and do the paperwork, you could do that for 2 days and then go out and do 10 inspections and then have to go back and sit for 10 days. So this sped up the process quite a bit. So
that's helpful, Matt. Thank you. I think the key takeaway that I'm hearing is really, I mean, you said you got lucky. I think you're being humble. You have a great relationship and you've worked hard to build that relationship. But really what it comes down to is justification. And in your case, it was risk aversion, if I'm not mistaken. So thank you for sharing that with the audience here. I recognize where we're at time. So that's the end of our presentation, and we'll open it up to for questions.
Hey, Dave, we're actually moving. We'll do questions at the end, but thank you guys. I am glad that I'm in clean water. That sounds like a lot of headache moving through all that stuff. Let me see here. So next, I wanted to turn it over to Bill and Ashley. I don't know if you can give up control, Dave, and then move to the next slide. And great. So Bill, I don't know if you are able to click on that view options.
I've got control.
Top right. Okay, great. Thanks, Ashley. We'll take it away.
Okay. All right. So good morning and thank you. I'm Ashley, the Success and Innovation Manager at Fontus Blue. So today, Bill and I are going to talk about how data-driven decision-making enabled us to optimize treatment and save on chemical costs at a water treatment plant in Mentor, Ohio. First, I'd like to hand it off to Bill, the area manager of Aqua Mentor Division, to discuss with you the treatment plant and the challenges they were facing at Mentor. Bill?
Well, hello to everyone. It's nice to be here today, and thank you for having me. Okay, a little bit about the Mentor plant. As you can see on the slide, it's a conventional treatment plant built in 1958 with several expansions over the years. The plant includes rapid mix, flocculation, sedimentation, and filtration. And we're very fortunate to use Lake Erie as our source. That's the 4th largest freshwater lake in the United States. Our single intake resides about 2,500 feet out into the lake in about 18 feet of water. And we serve approximately 75,000 people in Central Lake County, and this is just east of Cleveland. Our customers reside mostly in Mentor and Kirtland areas with 32,000 connections. The plant has a capacity of 18 million gallons per day, and we average about 6 or 7 million gallons per day, depending on the time of year. Next slide, please.
I double clicked, sorry. There we go.
Yeah, some of the challenges at Mentor that we face are mainly a few items. With turbidity, the lake conditions can change rather quickly with winds and storms. We're fairly close to the shoreline, as I mentioned, about a half mile. We can also be influenced with runoff from a nearby river as well. Disinfection byproducts can also be a concern for us. This is primarily due to aged water, so obtaining the optimal chlorine dose is very important for us. And then, and of course, cost is always a concern, right? Like everything else these days, chemical pricing has gone up across the board in the last 2 years with tighter supplies. So we're always looking to optimize our chemicals. Next slide, please. Yeah, a discussion about the normal standard reactive process at the plant. Our treatment operators are very good at recognizing changing conditions in the raw water. Of course, this system's monitored 24/7, so we're well aware of when these changes occur. Reactively, we make chemical dosage changes to account for a treatment event, but where we stand to improve is when to turn the chemicals back down. And as an operator myself, sometimes this is not always so obvious, and it's really easy to overfeed unnecessarily. So again, where we stand to improve is in our proactive decision-making with regards to chemical treatment.
Thanks, Bill. So as Bill just mentioned, the way operators at Mentor were making decisions was very reactive. And really that is the standard for most water treatment plants. Everybody operates that way. The result of this is that a lot of plants end up over-treating, just like Mentor had a tendency to do, especially when raw water quality was favorable, when turbidities were low, organics were low. There seems to be a tendency to respond to a water quality event, Bill kind of alluded to this, by throwing more chemicals at the problem and treating it effectively. But when raw water quality returns to normal, chemicals are back down, of course, but still elevated relative to where they could be. So in order to optimize chemical use, whether or not the plant was experiencing a water quality event, we had to adjust to a more proactive approach to treating water. So for the purpose of optimizing chemical use and saving chemical costs, it's especially important to not just wait for a water quality event, but to focus on optimizing regularly. This proactive approach involves looking for areas to optimize again regularly, regardless of whether there is a water quality event, and to make the appropriate chemical change, and then log and reflect on the outcomes. To achieve this operationally, we implemented a system of data-driven analytics software for Mentor. This software is used to monitor water quality and forecast water quality goals and compliance values. We also implemented what we call a digital twin of the water treatment plant. Basically, this is a digital version of the water treatment plant that uses machine learning to forecast the impacts of chemical change based on historic data from the plant. And finally, we implemented a digital log to capture the insight or the area that we were looking to optimize, the action, which was the chemical change that they made or didn't make, and the outcome of the dosing decision. So this digital logging of insight, action, and outcome is absolutely critical to this process. It provides a shareable, searchable record of dosing decisions, so operators between shifts understand why a chemical change was made. And a record is maintained that can be referenced, a week, a year, or even years later. So when operators come and go, the institutional knowledge is left for their predecessors. So the analytics software that we implemented was cloud-based and includes what we call key performance indicators for each of the water quality goals. So for each key performance indicator, a threshold is set to alert the users of the value status. So for instance, if the key performance indicator was within the goal range, it would be green. It would turn yellow to warn them if the indicator was nearing a bad value, and it would turn red when we were outside of the goal range. And then we can immediately respond to it. A daily report is also sent to users via email. So including managers like Bill to alert them if one of these values is outside of the desired range so that that action can be taken immediately. The digital twin that we implemented is called Virtual Jar. So when making dosing decisions more frequently, it can be unrealistic to run a real physical jar test at the plant each time. This is a process that can take hours to complete. By using historic data from the plant, a machine learning model was made to predict the impact of chemical doses on current water quality. This allows the operators to run a virtual jar test in just a few minutes with a focus on improving multiple water quality objectives and lowering chemical costs. For Mentor, the water quality goals that we forecasted were settled turbidity and organics removal, as these were typically the challenges they were dealing with: high turbidity and DBP issues related to chlorine dosing and organics. With all of these software upgrades came an improvement to the process workflow of the plant. So just entering data is not going to be enough. Again, the operators had to become proactive in their decision making. So operations meetings are regularly held to discuss treatment and treatment goals. We look at current water quality and assess our water quality goals. So current raw water quality and where we want the finished quality to go. Is the quality good, or is there something we need to try to improve? For example, is turbidity high, settled turbidity, high filter run times? Are we forecasting a high DBP sample requiring improved organics removal? So next we run simulations. Typically we discuss with the operators what they think would be a good treatment change and try those chemical combinations. Bill mentioned they have very good operators. They have great operators at Mentor, but this system won't work on its own. We need the experience of the operators who understand how the plant responds to certain chemical changes. So when we're having these discussions, do they think they might be over treating? Are they worried about a turbidity event soon, maybe, you know, due to a weather change, a storm coming in, so they don't want to aggressively lower chemicals? And finally, when the simulations are run and the forecast in settled turbidity or organics value is made, we can decide on a chemical dosing change to either improve water quality or to lower chemical costs without sacrificing water quality. So the operator then implements the change, and after an appropriate amount of time, maybe 6 hours later, the next day, depending on the flow of the plant and how long it takes to see a change in the plant, the outcome is measured and the whole insight, action, and outcome are logged and reflected on. So with this improved process, Mentor has achieved really fantastic measurable outcomes. They have consistently met their compliance goals with turbidity and DBPs, and still they've managed to save over 20% in chemical costs last year. And that's even, you know, with increases in prices that were maybe not as bad as we're seeing right now, but somewhat of an increase in prices last year. So in particular, they saved in powdered activated carbon, permanganate, and alum use, because the digital tools allowed them to forecast the impact of lowering these chemicals on organics removal and on turbidity. And because we log these decisions, the operators have the opportunity to reflect on the outcome of the change. So the change to the plants and these improvements aren't done overnight. Incremental improvements allow operators to become more comfortable and confident that they aren't under treating. They now use in general a lot less alum than they had been previously comfortable with. So this logging process is critical for this reason. So in summary, to save on chemical costs, it is vital that optimization is a regular focus of the plant. Dosing decisions should be logged and the outcomes reflected on, again, regularly. I want to thank you for your time today, and we are happy to answer any questions you may have later, or feel free to shoot us an email. Thanks.
Thank you.
Pass it back to Alex.
Awesome, thanks both of you. So now we will move on to the Q&A section. So we'll probably stop sharing the screen, and if the speakers were able to turn their video on for this section, that would be great. If not, no worries. And if you ask a question and we don't have time to get to it, we will compile a list and work on getting you those answers and share that with everybody on the call today. So one question that we did get was for Quinn, and it was basically, can you share any ROI for this specific use case?
Sure. Sorry, I'm not able to turn my video on, but for the use case described in the presentation, I think, the ROI was $1,002,000, and that was the ROI for the Atlanta pilot.
Okay, great. We did get one question for Dave and Matt and John. It was, are any or any information on like the financial impact to the city with implementing this new technology? Like, you know, did you get any measurable returns after implementing the system?
So it's just starting to evolve. It's a long-term process, but with the non-blockages, so we're not having to go out and do those. Our treatment, our pump stations do have less grease in them, so we're not having to clean those as often, which obviously means there's less grease at the treatment plants. So that's being a big thing. We're much more closely watching the IPP stuff. So we are watching chemicals. Our treatment plants aren't having to use as much chemicals because we are being much more cautious and trying to give them information of what's going on and getting them to lower the numbers, even if they are below what they need to be.
And then I'll just build on that, if I may, just to say that another aspect of the financial impact that we'll be looking at as Matt said, this takes time to sort of realize, are some of the things John spoke to around not having to go back and forth to log notes in his computer and so forth. So we'll be looking at the man-hour impact as well to add to those other important aspects Matt spoke to.
Yes, if I can, just one more thing. When I started, as I said, I was doing about 3 different jobs and physically entering in all the data. Now we have streamlined it so most of the data is automatically entered, and John is easily doing twice as much work as I started doing every day. So manpower is a big thing.
Yeah, definitely. It's really challenging when you're starting something out. It takes time to like see when things improve. So yeah, excited to hear what you guys find. So one question that I do see here for Bill and Ashley is, are the sensors provided by Fontus? Is Fontus software compatible with like all sensors, or do they require a specific protocol? Or are you good with all kinds of manufacturers?
Yeah, so the nice thing about it is there is some component of manual data entry for, you know, lab values, things that you wouldn't really use a real-time automated sensor for. But when it comes to, you know, any data, temperature, pH, things like that, that can be read on a sensor, we can actually just use the sensors that are already in your plants and connected to your SCADA. And we actually have a device that has basically one-way traffic. So I know a lot of people don't want their SCADA connected to the internet, but they can either upload it to another database or connect this directly, and the traffic will only flow out of the plant. No data will flow into the plants. So no danger of hackers or anything like that. And so we're just using what you already have in your plant in order to send us real-time data.
Nice. It's always nice when you can play nice with the other equipment, for sure. So one question that we had that was back to Quinn was just a general question about the ROIs. So it says, what ROI is acceptable for any of these technologies? For example, if a utility is saving $100, how much are they generally willing to pay? You know, $10, $50, $90.
So in the case of the technology that I described, there are some cost savings, but it's really more of revenue predictability. And the way we look at it is, if you look at the utilities revenues from water and sewer fees, we would say that their return on investment is usually 10 to 15% of that total revenue amount.
Okay, that makes sense. And then one other question we had for Bill and Ashley was kind of about your workflow and the in that flow chart you had where you were running simulations to sort of figure out what you were going to treat the water with. I guess, could you just elaborate on that process and how you built out your digital twin and sort of how you run those simulations?
Yeah, so basically what we do, we've been working with Mentor for more than just the past, year, where we've made all these, chemical cost savings. For about a year before that, we were heavily collecting data. So again, I mentioned, real-time connection to the plant, so we were pulling in that data. And then one of our modelers, our programmers, basically takes all of that data, at least a year's worth of data, but the more you have, the better, and runs some machine learning algorithms on it to develop a model that best predicts what chemical dosing, how it's going to affect the particular water quality that you're entering for that day. So, occasionally we'll do rebuilds of models that once we get even more data going in, but we can, see in the model, what is impacting the water quality, the finished water quality more, which chemical is having the most weight on it. So there is, a process. If you have digital data readily available, it really only takes a couple of weeks to build a model. And then, that's a model that we can use for, again, long term.
Okay, very cool. Yeah. I think we probably have time for one more question, but I think one thing maybe we can pose to all the panelists is part of the reason that we chose this topic was just discussion of like infrastructure spending and different kind of clever ways to tap into funding sources. And so if any of you had any insight on, maybe clever government spending sources that you're planning on tapping into or leveraging in the near future, it could be interesting for some of us to hear about.
Yeah, so Dave here, I'll speak to that. So we're at Aquatic Informatics, we're not looking to tap into or help our customers tap into any new sources of revenue. I know there's the infrastructure spending bill, which puts some funds there, and certainly using technology to manage and extend the lifespan of the collection and water distribution systems is an important part of that. But really, from our standpoint, it comes back to what Matt said, and that is intelligent justification and working with our customers to help them see that by not bringing in technology tools and just sort of standing pat and letting the same old take place, that actually costs a whole heck of a lot more than the initial spend on a technology tool, and that return on that investment, which takes some time, and we help the customers figure out how much time that that can be and do that hard math. But really, it's about positioning the technology intelligence, sort of like it always has been. It's always been about justification. If the problem's big enough to fix, we're going to find some funds to fix it. And so it's about helping our customers justify what they're trying to do in order to meet their larger tasks at hand.
Great. Thanks, Dave. Yeah, we are pretty much out of time here. So I did want to just thank everybody for logging on, and I will turn it back over to Shirley. Thanks.
Thank you, Alex. You did a phenomenal job moderating. Never the moderators don't get enough credit, right? But all the speakers do. So thank you, Alex and Brent, again for co-hosting this and leading us. And again, to all of our speakers. We had here Quinn Jackson from Olea Edge, and we had Dave, Aquatic Informatics, Matt and John from City of Marlborough, Massachusetts, and last but not least, Ashley from Fontus Blue and Bill from Aqua Ohio.